So we are starting lesson 2.1, transformations of quadratic functions. Our essential question today, how do you describe and write transformations of quadratic functions? First thing we need to review is what is vertex form when we're specifically looking at the quadratic formula. So f of x equals, quadratic form's vertex has a value that we are going to represent as the variable a in front of the parentheses. Inside the parentheses, we need x minus some value of h. The parentheses is squared. That's how we know it's a quadratic function. If the parentheses is not squared, it's not quadratic. And then we need the plus k. We are used to seeing values in the a, h, and k locations. And so today we're going to look at what does it mean when these are values. So there are a couple things you need to know about vertex form. First, there is actually a vertex that you can recognize straight up from this form. It's the coordinate point h, k. So whatever number you're subtracting is the x value, and on the outside, whatever number you are adding is the k value. That is your vertex. This a, the variable a tells us if we are going to be facing upward or if we are going to be facing downward as a parabola. The value of a also tells us if we are going to have a vertical stretch or a shrink. So here's a quick couple of little reminders of what the a, the h, and the k will do. Now let's talk specifically about what kind of things do we need to see in the a, the h, and the k to make our translations possible. So if I want a horizontal translation, this is not a horizontal stretch or shrink, so please do not confuse that with this. Horizontal translation means I'm moving horizontally to the left and to the right. So there are two different ways that you could either choose to move to the left or choose to move to the right. This h value right here is what we are used to looking at to determine whether we moved left or right. If we were subtracting a number, so if I was subtracting 2, if I was subtracting 10, if I was subtracting a number that was bigger than 0, we knew that we moved to the right. So if the number was bigger than 0, I went ahead and I moved to the right. And because we're used to seeing that as a subtract inside. Now, if I wanted to move to the left, you are used to seeing that as an add on the inside. We know that vertex form has to have a subtraction. So what number does h have to be to where it would turn to a add problem? It would have had to have been smaller, 0. So if you're subtracting on the inside, the only way to subtract on the inside is if this h value right here was bigger than 0. The only way to add on the inside is if this h value right here was going to be smaller than 0. What happens if it was actually 0? It wouldn't have moved to the left or to the right. If this was 0, it would have stayed exactly where it was. So if you are bigger than 0 or smaller than 0, so you move to the left or the right. So let's look at vertical translations. This was vertical, moving up or down. What letter told us that we were moving up or down? It was what we were doing out here. So it was the K. We are used to seeing either on the outside, we are going to be subtracting, or on the outside, we are going to be adding. This is how we are used to seeing it. But let's go ahead and convert that to a K value. So on the outside, if this needed to be a subtraction, what value did K have to be? For this to be a subtraction on the outside, this k had to have been smaller than 0. This would have moved us down. On the outside, if this were an add number, what number would this have to be? It would have to be bigger than 0. And if this was bigger than 0, we were actually adding a number, this would have moved us up. So to move down, this value right here has to be smaller than 0. So I'm minusing something because I'm subtracting on the outside. To make him move up, this value right here has to be positive, and then he would have been actually moving up something. If I wanted to reflect across the x-axis, that was the number in front of the parentheses. For our purposes, that is represented by the variable a. The only way to make it reflect across the x-axis, meaning it was on top and now it's facing down. So if this was my parabola and I wanted to reflect it, it would have gone downwards, and it's now reflecting down here. It's for reflecting down. The only way to go that way would have been if a was negative. So if a was smaller than 0. We are used to saying this as multiply on the outside by -1. So if I were to do this, I have my function f of x. If I wanted to reflect it, I now have a negative x squared, because now I'm down here and I'm a quadratic function. Now if I'm reflecting across the y-axis, this is my parent quadratic function. Reflecting across the y meant that they turn this way and switch places because that's the y-axis. Well, the parent function is symmetrical. So if I was a u and I flip my u, I actually end up looking the same. So what are we used to saying on this? We are used to saying that we would multiply the inside by -1. This is how you would reflect across the y-axis. But if I actually multiplied the inside by -1, because now it's on the inside, well, that meant that this entire thing got squared, which meant I had a negative times a negative, which is a positive, and an x times an x, which is a x squared, which is why the parent function is the reflected across the y-axis function, because they're the exact same. They just replaced each other. So it is its own reflection. So now let's look at our horizontal and our vertical stretches and shrinks. This involved all of our A's. So let's do vertical. We're used to seeing our vertical. So if I am stretching, I'm going to stretch away from the x-axis because I'm stretching. So if my vertex is going to be stretching up, and if I stretch up, because that's what vertical is up. So if I'm stretching up, I'm going away from the x-axis. And the only time you actually stretch is if your a was bigger than 1. We are used to calling this to be multiplied on the outside by a number larger than 1. This is what we are used to saying. This is the algebra way of saying it. Now, if I'm not stretching, if I am shrinking, so it's a vertical shrink, which means I'm shrinking it down, which meant I'm getting closer to the x-axis. So if I'm shrinking, I'm going to shrink towards the x-axis. And the only time that ever happens is if I am positive, but smaller than 1. So what we are used to saying is that we multiply on the outside by a number smaller than 1, but it had to be positive, because if it was negative, then we're reflecting. Now, horizontal technically does not exist in vertex form. So we have to mess with the math problem and make it be vertex form, and then it actually starts looking like a vertical stretch. If I was a horizontal stretch, you were going to stretch away from something. Now if it was horizontal moves this way, and the axis that you are moving in relation to is away from the y-axis that sits here. So you're moving away from the y-axis. And the only time you ever do this is if you are smaller than 1 but still positive. So we are used to saying that this would be a multiply on the inside by the number smaller than 1. That's what we are used to saying a stretch look like, a horizontal stretch. But you know a horizontal stretch is actually going to be a vertical shrink. Notice the A's are the same. So if I am horizontally stretching, that is the same thing as saying I was vertically shrinking. These are the same as each other. So what if I was horizontally shrinking? If I was shrinking, remember horizontal means this way. So if I'm shrinking, I'm getting closer to it. So that means I'm moving towards the y-axis. The only time I ever move towards the y-axis is if I was bigger than 1. So a horizontal shrink is the same exact thing as a vertical stretch. And we are used to saying that this was a multiply on the inside by the number larger than 1. So a horizontal shrink will end up looking like a vertical stretch in vertex form. A horizontal stretch will look like a vertical shrink in vertex form. Horizontals cannot be seen in vertex form because there's nothing in front of the x in vertex form. Verticals are the only thing you can see in vertex form.